If the discriminant is negative, I have nothing to say, but the solutions are not real. If the discriminant is a perfect square, like 36 or like 4, then the answers will be, the solutions will be rational numbers. If the discriminant is 0, I will say there is only one identical solution or two identical solutions, and they are rational. And they must be rational. And what is the last possibility, last option is? Well, when I cannot take the square root from 44, or from 3, or from 11, or from 7. So then the solutions would be two distinct irrational solutions. I'm going to put distinct. They're not going to be the same. Not identical. Distinct. Distinct irrational solutions. Good. So now let's look at different problems concerning the discriminant. And I promise after this, there is no more new material. This is it. Determine the discriminant of the quadratic equation below. Okay? And then identify the quadratic equation has two rational solutions, two irrational solutions, one repeated real solution, or two complex. Complex means not real. Two non-real or complex, same thing. Two solutions that are not real. So we have 7x equals 4x squared plus 1. They're not asking us to solve the equation. They're asking us to determine the discriminant and decide without determining anything. So I cannot determine the discriminant as long as the equation is not in the standard form. So what do I need to write? Anyone, please? What do we need to do first?
Be 4x squared would be first, and then minus 7x.
Plus 1 equals 0. Excellent. We have to set it up so that it's ready to identify A, B, C. A, B, C. B squared minus 4AC is B squared, 49. It must be positive. Minus 4 times A times C. So this is 49 minus 16, which is 33. Good. So, because it is 33, let's go through the list of options. First option, no, it's not a negative number. Second option, no, 33 is not a perfect square. Third option, no, 33 is not 0. Last option, two distinct irrational solutions, because it will stay as the square root of 33. Two distinct irrational solutions. Two distinct irrational solutions. So I already know what to expect. Any questions? Good. So the value of the discriminant is 33. And then 2 complex solutions? No. 2 irrational solutions? Yes. 1 repeated real solution? No, because the discriminant is not 0. 2 rational solutions? No, because I cannot take the square root from 33. Good. So now we're going to discuss this. But first I want to work on one problem, like this one. 5x squared equals negative 10x. I need to make a point on this. And then we'll continue with those problems. Okay. This is quadratic. It will have 2 solutions for sure. And what do I need to do? What will you do first?
Put the negative 10x over like a positive
Absolutely. So 5x squared plus 10x equals 0. I will simplify dividing both sides by never variables. Never variables. Only coefficients or constants that I can simplify. I'm emailing you now a test from last semester when I taught this class. I want you to have it so you can look at it. I'm emailing it to you right now. Please confirm, if anybody can confirm the receipt of this. Okay, so what we are going to divide by. We always try to simplify as much as possible. If we don't, we're getting in trouble. We always do.
5.
Yes, we will definitely divide both sides by 5. Just one more second to click on students here. So all in students. And please confirm the receipt, if anybody can confirm the receipt of the previous test. Okay, very good. So we are going to divide both sides by 5. And then we have x squared plus 2x equals 0. When the free term is missing, you should only, forever, you should only think of factoring. Nothing else. Taking square roots? No. Completing the square? No. Quadratic formula? Absolutely not. So when the last term, when the so-called free term, no variables, free term of variables is missing, you should only think of factoring. It takes a blink to solve this. So, anybody please? How do I factor? Remember the strategy. If you skip any of the steps in the strategy, you're making factoring very difficult. So, anybody? Anybody, please? This is really the most simple situation. So what do we need to factor here? Anybody? How do we factor x squared plus 2x, please?
X plus 1?
We have to go through the strategy. The strategy says descending order, it's a binomial, greatest common factor.
X.
Say it again.
X.
Of course. What is left in parentheses?
2.
I started with two terms. I have to have two terms. I cannot have one term.
X plus 2.
Indeed. So then I have two options, x equals 0 and x equals negative 2. So when the free term is missing, this should take 3 seconds. Do not try any other method. Not taking square roots is not possible. Not completing the square, it's too long. And not the quadratic formula. This is always the easiest, factoring. Okay, so now let's go and look at some problems here. Not here. Can anyone confirm the receipt of that file?
We got it.
Okay.
Yeah.
And it says test 4, correct?
Yes.
Perfect. So please look at it before Thursday. Okay, so let's look at this equation. X squared minus 8x plus 10 equals 0. Will you factor? No, because the product is 10, so you only have 10 and 1 or 2 and 5. It doesn't work. Are you going to use the quadratic formula or the square root principle or property or method? Quadratic formula or the square root? If you want to use the square root, you have to complete the square. This is not ready for taking square roots by any means. So, what will you apply? Which method makes sense here? We already said that it's the factoring doesn't work. We already said that the square root principle is a hassle because it's not ready. You have to go through all the steps of completing the square.
You do the quadratic.
Absolutely. Absolutely. The quadratic formula is the method for this one. Great job. Good. Good. X plus 7 squared equals 25. Factoring, quadratic formula, the square root principle.
You do the square root.
Absolutely, it's ready. It's ready and waiting for us. Excellent. X squared plus 2x equals 0. Square root, quadratic formula, factoring.
Factor.
Yes, we just looked at an example. Never do anything else if the free term, the free of variables, the free term is missing. Never, ever, ever. Factoring quadratic formula, square root. Factoring, quadratic formula, square root. Anybody? Factoring, quadratic formula, or the square root property, or principle. Anybody would like to give it a try? If you look at the example or the problem, what would you say? No one?
This is chapter 5 and 6 again. I have no idea.
Not at all. This is what we just discussed a minute ago. Which method do we apply to solve this? Factoring, quadratic formula, or the square root?
Square root?
Of course, it's ready for the square root. Of course. That's all there is. Good. Good. So let's work on this problem. We're given the revenue, and the revenue function, let's write it down. So the revenue is R of x, negative 0.1 x squared plus 70x. Find the values of R of 12 and R of 55. That's the first thing. We discussed this. This is very simple, as long as you understand to plug it in. If you don't plug it in, you're going to work harder. So the function is negative 0.1 x squared and then plus 70x. First you enter the function and then directly go to second and table and plug in 12 and plug in 55. And make sure they're asking us find the values of this and this. It doesn't say out of 12 and out of 55, how many pairs, how many, find the values. It doesn't say how many decimal digits. Normally for money, we have 2 decimal digits. So let's take a look. Okay, it's exact, that's why. So 825.6. And the other one, 3547.5. Good. So we found the values. Okay, so this is 825.6. And the other one is 3547.5. Good, that's the first part. Part B. How many pairs of sunglasses must be sold in order for the revenue to be 10,000 per week? So this is part A. And in part B, we want the revenue of X to be 10,000. So I have to replace the revenue by 10,000. So 10,000 equals negative 0.1 x squared plus 70x.